this presentation is to give some reminders to year twos who are in retrieval. So first of all, passive solar design is when we use the solar energy in order to heat a building. So basically the sun rays are going to be heating the inside of the building, and this heat is going to be released during the day. So in order to achieve that, you need to have thermal mass inside the building. The thermal mass is the material which is going to absorb this heat and release it later. So I'll tell you a bit more about this. The other thing you need to make sure is that you're going to have windows. So in the north hemisphere, these windows are going to be on the south side to ensure that there's a lot of winter solar energy that go inside the building. You will need to make sure also you have loads of insulation inside the building so that you can keep this heat inside. And you need to make sure you're going to have shading as well, like an overhang here, to make sure there's not too much summer sun. So thermal mass, materials with high thermal mass have high heat capacity, meaning they can keep the heat, and high conductivity, which means that they conduct heat. So they're not insulation. Thermal mass is able to keep heat effectively and to release it later. So timber has not good thermal mass, doesn't have good thermal mass. Water, stone, brick, and concrete have good thermal mass. You don't need that much thermal mass. Perhaps 100 millimeters is about right. But the thermal mass must be located internally behind the solar gains area. Sorry, there's an error here. So one thing you need to remember is the thermal mass that's outside the building doesn't work, because you're going to have insulation, for example, in your walls here, which prevents the thermal mass to distribute the heat to the inside. It's important the thermal mass needs to be inside the building so that it can actually release the heat inside the building. The second aspect of designing with the sun is shading. So you need to ensure you're going to have good shading during the summer season. There's different kinds of shading systems. These are the main ones. So the horizontal single blade is also called an overhang. It's a horizontal shading system which works really well on the south facade. You can have multiple blades or louvers, which also work very well on the south facade. On the east and west facade, you might have vertical fins, which may be just simply vertical or maybe slanted like this. Or you can also have something called a neck crate. So there's other more complex systems, and you can also use, for example, meshes, but these are the principal external shading systems. Now, the most effective shading system is to have, when you have a south-facing window, to have a horizontal overhang. The horizontal overhang works really well because it does allow for the winter sun to enter inside the building, but is really good at preventing the very high summer sun to come inside the building. Daylight. So daylight is normally considered separately to sunlight. It's indirect light. So daylight comes from all the directions, whereas sunlight is going to be represented as coming from the south. So daylight is reflected light. It can be reflected on the clouds, or it can be reflected on the ground, on other buildings. And it comes from all the directions. So you can see here the daylight coming from every direction. The sunlight comes from the direction of the sun, and sun rays are always parallel. So on this diagram here, you can see that the sunlight is represented coming from the sun, and you have some daylight which comes from the north here. Natural ventilation is often represented with kind of wavy arrows. So natural ventilation is ventilation with natural movement of the air. You're not using a fan, and therefore it's called natural ventilation, as opposite to mechanical ventilation. If you're using natural ventilation, the air will enter the building and it will be heated by people, and then the air will rise up. The air, when it gets hotter, always goes up. In order for the air to go down, it needs to hit something and perhaps go down. So that would only happen when it's very windy or if the air is being cooled down. If you're using natural ventilation and you haven't got a fan, it's important to remember that the rooms need to be sufficiently narrow in order to ensure that the air can go far enough. If you have a very deep plan, the air is not going to be able to go through your entire room. So if you have single-sided ventilation, this is when you have a window on one side, the rooms need to be less than twice the floor to ceiling height deep. That's the maximum depth of the room, is twice the floor to ceiling height. Now you can increase that slightly if you have bottom and top openings in your window, meaning if your windows are quite high and can open at the bottom and at the top, then the maximum width of the room is 2.5 times the room's floor to ceiling height. One thing you can do to improve things further is to have windows on both sides of the room. In that case, this is called cross ventilation, and the maximum width of the room is 5 times the floor to ceiling height. Now, if you're using natural ventilation, you might also want to use thermal mass. Again, materials which have high thermal mass can be things like concrete or bricks, for example. Or if you have a floor of tiles on the top of concrete, this would be high thermal mass. So what you can do is that you can have opened windows during the night, and this is going to cool down your thermal mass. And the heat from the day of the thermal mass is going to be taken away by the nighttime ventilation. So the nighttime ventilation is going to cool down the thermal mass. And then during the day, the thermal mass just absorbs the heat from the inside. So you need to make sure, if you're doing so, that you have a system of opening the windows which is not going to compromise the security of the building. Now, water management. Many of you want to use rainwater inside their buildings, for example, for the toilets. So in order to do that, you need to make sure that you collect your rainwater in a rainwater tank. And then you can redistribute this rainwater, normally it's filtered, to the toilets and perhaps for irrigation. So you need to remember that water always goes down naturally, and in order to get it to go back up, you need a little pump. But one thing you don't want to do is to get the water to go along long, complicated paths, because that might create blockages. So you're when you do your final representation of environmental design, it's often a good idea to represent winter and summer separately. So in this diagram here, which is a diagram representing how ventilation and sunlight is being dealt with during the summer, you can see you have the natural ventilation, and you can see the high summer sun is being prevented to enter the building thanks to the overhang here. You might also want to add daylight if you're using daylight from the north. It's not represented in this diagram here, but it's a good idea to add that to your diagram. You may also want to add any other technical systems that you're using, like for example here, this is the tank for the rainwater, and perhaps any heating or cooling system in this case if you're using any. For the winter, here you can see that in this diagram we're using a heating system. You can see there's no natural ventilation, just the air stays inside. And you can see that the winter sun enters the building here. So I hope this very quick presentation was useful, and please do contact me if you have any further questions.